This is a lesson on the first law of motion. In order to talk about the first law of motion, we need to first explore the ideas of mass and inertia. Mass, of course, is the amount of matter in an object. If there's more matter, there's typically more mass. Inertia is the tendency of an object to remain at rest or to remain in motion at constant velocity. And how these two are related is that mass, it's a property of mass to resist motion. So inertia is a property of mass. And if something has more mass, it has a larger tendency to resist changes in its motion. If it's smaller, it's easier to change its motion. And the first law relates these two with the idea of force. A body at rest remains at rest, or if in motion, remains in motion at constant velocity unless acted on by a force. Okay, and so there's a couple of things we need to unpack in there. We call this the law of inertia. Two implications come from Newton's first law. The first being an object moving at constant speed has no net force on it. If there's no changes in its motion, then the first law says there must be no net force on it. And does this make sense? A constant speed, that means the acceleration equals zero. There's no acceleration going on. What it doesn't mean is that there's no forces on it at all. There may be some force in this direction and some force in the other direction, but overall they add to no net force and resulting in no acceleration. An implication of this is that the path will continue along a straight line. If there's no acceleration, that means there's no change in the velocity vector. And so that there's no change in speed and there's no change in direction. And this may be familiar to you from like movies about space where something will float and float and float in space with no forces on it. It's moving at a constant rate because there's nothing to slow it down. The second implication here is that an object isn't experiencing acceleration, has a net force on it. If it's experiencing acceleration, we know that there must be some balance of force in one direction or another that results in a change in that motion, the change in the velocity vector. If there's a speeding up, the net force is in the direction of the velocity. If it's slowing down, there's a net force opposing the velocity. One example that I wanted to talk about with you that kind of exemplifies this concept is the idea of casting a fishing line. When you throw the bait and weight out into the water, you use a long stick in order to do it. And you rotate that stick essentially in a circle with some radius. And at some point you release it and the bait and the weight will continue along a path. And what we know is because even if you move this along a line with a constant velocity, because the velocity vector is changing direction, there's some sort of centripetal acceleration. It's experiencing an acceleration, and in this situation, there must be some net force being applied in order to keep it moving along a circular path. But as soon as you get to and release it and get to the end of the circular path, whatever the velocity is at that situation, at that point, it's going to have that's going to be the beginning of the next motion. And the force of the rod is no longer on it. And the bait and the weight are free to undergo their next stage of motion, which would be free fall motion in order to hit the water. And that initial velocity would be whatever velocity it had here, and we can assume the direction of the vector is tangent to the path because that would be the straight line that Newton's first law suggests. If there's no more force anymore, that velocity vector would continue in that direction, and then it becomes under the influence of gravity, and that would be another accelerated motion.